Wings are a crucial part of Bloodhound's design. They're most commonly used to generate lift, and to show how effectively they can do that, we visited another local speed record holder.
I'm Zara Davis and I'm a speed windsurfer, and I'm the fastest woman on water, over a mile on any sailing craft, and the fastest woman on a windsurfer over 500 metres. I did 45.83 knots, which is equivalent to 53 miles per hour. So for speed sailing, we use a sail that's probably got a bigger camber, a bigger foil than you would for recreational windsurfing. We basically have a plastic piece that sits onto the mast called a camber inducer that has a carbon batten that sits in it, and that basically holds it in the shape of a wing. So if you imagine an aeroplane wing, it sits in that shape, but obviously it's upright and not horizontal, and that gives you the lift. The thing that probably slows us the most is bumpy water. And the combination of flat water and windy conditions are quite difficult to attain. So one of the easiest ways of achieving that is to dig a trench. Because if you dig a trench somewhere where the wind is pretty guaranteed, you know when it's going to blow, which time of year, and in which direction it's going to blow in consistently. You can dig a trench at the right angle to the wind. And for windsurfing, kite surfing, we dig the canal at about 140 degrees to the prevailing wind in Namibia.
The sail that Zara uses generates so much lift that she can actually travel faster than the speed of the wind. However, Bloodhound will mostly be using wings to keep the car stable at speed.
So we basically spent 3 or 4 years probably coming up with a shape of the car that doesn't generate any massive change in lift between stationary and 1,000 miles an hour, and actually as the car pitches and heaves, so it changes angle of attack, generates very little changes in the whole lift throughout the whole run profile. So a lot of time to make sure it isn't working like a wing. So the most obvious wing, if you like, on the car is the fin. The one we got here is on the show car. This is much smaller than the real thing. Unlike the sail on a windsurfer, it's a symmetric aerofoil. So as the car, if you like, yaws a little bit, it works a bit like a wing at an angle of attack, generates lift, and then pulls the car back into a straight line. The other things we have on the car that are a bit like wings are the winglets. So we have 2 at the front, 2 at the back, and they're working there very much just to help with the trim of the car. So we don't really need them to hold the car on the ground or generate lift, but particularly when we turn the rocket and the jet on and off, it just gives that option for that little bit of trim. For the first year's running, they're being actuated. Although we are detecting the weight on the wheels, we're not using that to control those wings. If we see that the control system thinks it needs a lot more lift or downforce than we're predicting, then Andy will get an abort signal, because that's showing that the aerodynamics are now going outside of what we've predicted. So we need to stop, look back and see where we need to make those changes. So although they're actuated, as we get some experience for the different speeds, we're hoping to find a single setting for each speed. We can just lock those 2, so we don't need them moving at all. And the whole idea is that it's when we get the high speed runs that Andy's got just the right amount of load on the wheels, so he's got really good control all the way through the speed range.
To find out exactly how a wing creates lift and why Bloodhound is the shape it is, try these links.